Hello, I'm Lon Robinson, Marketing Manager at ON Semiconductor, and I'm here to talk about one of our most exciting new products. We have the ON Semiconductor Smart Passive Sensors. These are the world's first sensors that do 100% of their energy needs through energy harvesting. They have absolutely no battery or power connection whatsoever, which opens up a lot of exciting opportunities and solves a lot of application problems that are really plaguing the industry. So today I'm going to show you one example of how this type of product could be used to solve a problem in the industry. We're going to actually be showing a temperature sensor. And this form factor here is the actual sensor. This is the full functional sensor with all the power requirements, as I mentioned, inside. So what this sensor is actually doing, I'm placing it here on a bus bar, which is commonly used in a power utility industry for current transfer, and one of the indicators of degradation which can lead to catastrophic failures is when the temperature rises due to the resistivity increasing from degraded components. So right now I have two temperature bars, or bus bars I should say, side by side. This one is at room temperature and this one is heated up. So the temperature sensor right now is being placed on the room temperature bus bar, and it is in a wireless communication with this antenna here. So the technology utilizes an RFID protocol, which is a good technology because it's mature, it's been around for a very long time, and we're utilizing everything within the standards that are already established today. So that means that it can be tapped into a lot of existing ecosystems. There's nothing new or non-proprietary. Or proprietary that we are doing, so we don't need to worry about connectivity and challenges by tapping into different types of back-end networks. So this antenna does the communication. It also provides the energy in which the sensor gets its energy harvesting from. There's a constant communication going on. What's new about this sensor compared to existing RFID technology is instead of just using that technology for identification purposes and asset tracking and such, it's actually doing the high value sense function. And that's also first in the world within RFID to use that ecosystem to get a sensor function like this. So the ecosystem that we've set up has the antenna communication. That communication link then is built into this developer's kit, which is another thing that ON Semiconductor offers to make it very easy for designers to evaluate and test this technology. The great thing about this developer's kit is it not only does the interrogation function needed to read the sensor, but it then also has multiple back-end network connectivity options, such as Zigbee and Z-Wave and Ethernet and Wi-Fi and so on and so forth. So it enables customers to easily be able to collect the sense data and then also use that data to trigger all kinds of different IoT type of functionality. So in this case, after the sensor is read, it's being fed into the developer's kit board. There's a readout of the actual temperature reading that's being read on this on-screen display that's happening right here. Just for the sake of the demo and showing the functionality of the type of connectivity options you could do with a sensor like this, it's using the Zigbee interface to communicate with a standard off-the-shelf Zigbee color-changing bulb. So this color-changing bulb is set up to in a way where the color will replicate the temperature it's reading. So as it gets warmer, it goes from blue to green to yellow to red and so on and so forth. We're also utilizing the Wi-Fi connectivity function of that board to create a Wi-Fi network, and we got an app that's doing a readout of the temperature sensor real time. So you can see right now it's reading 23.0, 22.9 degrees now, which is the same readout that's on the board, and that is the number that is controlling the bulb, which is showing the blue color as of right now. So the demo that we're going to actually show then will then take this sensor and I'll move it from the room temperature board. This one's very hot to the touch, so if you could feel it, you could feel that it's quite warm. When I move that sensor there, it'll take a few seconds for the sensor to come up to temperature of the bar, but if you watch this app, you'll see that the temperature is going from 25 to 26.5 to 27.2. The light bulb is changing colors in coordination with the app, which is giving the real-time readout of the actual temperature. So the real temperature of the bar like I said, it'll take about 10 to 15 seconds. So as we watch this bulb, it's now turning yellow, 32.8. I'm watching the app over there. It's still climbing. When it gets to the point where it levels off, that means it's stabilized at the same temperature as the bar. So 35. It's going to go to 36. And you can see the bulb is also changing from yellow to orange. It's moving to red. So it doesn't take much time at all. And in the real application for this use case of the power utility bus bar application, that sensor would be placed in the bar at all times. So you wouldn't have to have this ramp up timing. It would always be reading real time, and the package would be adjusting as the temperature increases and decreases. So you would have some pretty accurate real time measurements going on. And I can see it's now starting to stable off, and I know that the bar is around the 42-degree mark. So now we're up to about full temperature right now. So that was one of the exciting possibilities. This type of technology comes in many different types of form factors. What I was showing was the type of sensor meant for on-metal attachment. I got another example here. This is the same exact type of sensor, just a different form factor. So this is a flexible type of form factor. You can see very small and thin. It's peel and stick. This type of application could go into clothing, it could be used on the wall, it could be used in a baby's crib. The applications are endless for this type of thing. So there's a lot of exciting different ways that you could use this type of sensor. The whole portfolio consists of temperature, pressure, moisture, and proximity, which could be used as a motion sensing type of functionality.